Welcome to the 8th grade Math Homework Helper Series. Tonight's homework is T-8, Dilations. Remember, a dilation of a geometric figure is either an enlargement or a reduction. The point at which the figure is either reduced or enlarged is called the center of dilation. The dilation of a figure is always the product of the original coordinates and a scale factor. The scale factor is always a number that is multiplied by the coordinates of a shape's vertices. A scale factor for enlargement is any number greater than 1. A scale factor for reduction is any number between 0 and 1. A scale factor that is negative indicates that the figure, once it's created, will be switching quadrants. If you have a scale factor of exactly 1, it means that there's not going to be any change in size. And you should ignore a negative sign when determining whether a scale factor is enlargement or reduction. For example, if you have -3, a -3 technically is less than 1. But for the purposes of determining whether it's for an enlargement or a reduction, you should ignore the negative sign and just focus on the 3. A 3 being greater than 1 would indicate that it's going to be an enlargement. Then you would look at the negative sign, and that would indicate that this enlargement is going to take place in a different quadrant than the original. Okay, we are going to start off by taking a look at number 3. We're going to find the coordinates of the vertices of the dilated figures below. And so we have a scale factor that we've been given of 3/4. Since 3/4 is greater than 0 but less than 1, it indicates that if we were to draw this out, it would be a reduction. We're starting with m for 8, and we're going to make an m prime with new coordinates that have been multiplied by 3/4. So if we take a look at the process to do that, we have 3/4 times 4. We'll start with the x coordinate. In this case, it makes sense to do cross product because we're going to reduce to 1s, which gives us a value of 3 for our x coordinate for the m prime. And in this case, again, we're multiplying 3/4 by 8. It makes sense to do cross product because we're going to be able to reduce the 4 to a 1, the 8 to a 2. 3 times 2 is 6 over 1, which would be 6. So our m prime coordinates are going to be 3, 6, and we can list them right here. Now we're looking at 6 and 9 as our original coordinates, and our a prime coordinates are going to be 6 and 9 multiplied by 3/4. I could do cross product for the 4 and the 6, but neither will be reduced to 1, so it's not really worth the effort to do that. 3 times 6 is going to get us 18. 4 times 1 is 4. It's an improper fraction. 4 goes into 18 4 times with 2/4 left over, which reduces to 1/2. Looking over at the 9, 3/4 times 9 over 1. 3 times 9 is 27. 4 times 1 is 4. 4 goes into 27 6 times with 3 left over, 3/4. And so our a prime coordinates are 4.5 and 6 3/4. For our p prime coordinates, we're going to be taking 10 and 12 and multiply them by 3/4. Again, I could do cross product, but it's not going to reduce anything to 1, so there's not much reason to do that. 3 times 10 is 30. 4 times 1 is 4. It's an improper fraction. 4 goes into 30 7 times, and it would be 2/4, which reduces to 1/2 left over, so 7.5 for our x coordinate for p prime. And for our y coordinate, we have 3/4 times 12. It does make sense to do cross product here because the 4 gets reduced to a 1, and that gives us 3 times 3 equals 9, would be 9 over 1, which then equals 9. So for our p prime coordinates, we have 7.5 and we have 9. For number 4, describe the following dilations given the following scale factors. Describe the dilation by focusing on the following words. Is it an enlargement or a reduction? Does it stay in the same quadrant or does it change quadrants? Is it similar or is it congruent to the original figure? Okay, so let's take these one at a time and look at each of these 3 situations. So we have a scale factor of 0.34. Well, it's smaller than 1 but larger than 0, so that indicates it should be a reduction. Does it stay in the same quadrant or does it change quadrant? Well, it's a positive number, so it should stay in the same quadrant. Is it similar or congruent? Well, the only way it can be congruent is if it's a 1. And since this is not an exact 1, it has to just be similar. Plus, it's a reduction, so we've made it smaller. It couldn't be congruent. Let's look at B, 3.5. Is it an enlargement or a reduction? Well, 3.5 is larger than 1, so it's certainly going to be an enlargement. Is it going to stay in the same quadrant or change? There's no negative number present, so it's going to stay in the same. And because it's an enlargement, it has to be similar, but it can't be congruent. Now we have -1. Is this an enlargement or a reduction? Well, remember, when you multiply by 1, you're actually staying the same, so there's going to be no change in size. Is it going to stay in this quadrant or change quadrants? Well, the negative sign on the 1 indicates that it's going to go to a different quadrant. And is it going to be similar or congruent? Well, if there's no change in size, it has to be exactly congruent. For D, we have a -2.5. Putting the negative aside for a moment, is it an enlargement or a reduction? Well, 2.5 would be bigger than 1, so it has to be an enlargement. Is it going to stay in the same quadrant or change? The negative sign indicates it's going to change. And is it going to be similar or congruent? The fact that it's an enlargement indicates that it has to be similar. For E, we have 1. Remember, a 1 is the only time where you're going to have no change in size. There is no negative sign attached to this 1, so it should stay in the same quadrant. And because it's no change in size, it has to be congruent. And then we have a -0.25. This indicates, putting the negative aside for a moment, that a 0.25 is larger than 0 but less than 1, so it's going to be a reduction. Is it going to stay in the same quadrant or change? The negative sign indicates that it's going to change. And is it going to be similar or congruent? The fact that it's a reduction means it can't be congruent. It has to be similar. Please use the work that was done for you tonight to help you to solve the additional problems that are on your homework. And remember, the key to success in math is not only working hard, but working smart.